Hello students, this is second lecture of the 12th science physics, and we are going to study about the rotational dynamics. And in first lecture we have seen the angular displacement, angular velocity, angular acceleration, and in this lecture we are going to see about the linear velocity, linear acceleration, and the force which is responsible for the circular motion. Now, for linear velocity, we have seen the formula for linear velocity in 11th standard. The formula for linear velocity V equal to omega r. Formula for the linear velocity is omega r. And if we want to write down the vector formula for linear velocity, then it is V equal to omega cross r. So the linear velocity is the vector product of angular velocity and radius vector. And if we want to show the direction of all these three quantities, see, if this is the path along which the particle or the body is performing circular motion, this is the path along which the body is performing circular motion, and at this instant, the body is at point A. Then this is the direction of radius vector. This is the direction of radius vector. And we have seen in last lecture that this is the direction of angular velocity. Angular velocity is along the axis of the circle. And now for the linear velocity, this is the direction of linear velocity. It is along the tangent of the circle. It is along the tangent of the circle. So for this equation, linear velocity is omega cross r. This is the direction of radius vector. You know that this is the direction of angular velocity, and the linear velocity is directed along the tangent of the circle. And so this linear velocity is also called as tangential velocity. It is also called as tangential velocity. Now we will move towards linear acceleration. We will move towards the linear acceleration, and linear acceleration is also called as centripetal acceleration. Linear acceleration is also called as centripetal acceleration. The formula for linear acceleration is r omega square, or it is equal to v square upon r, or it is equal to v omega. This is the magnitude. This is the magnitude of the linear acceleration of a body which is performing circular motion, which is performing uniform circular motion, and it is equal to r omega square. R is the radius vector, or it is the radius of the circle, radius of the circular path, you can say. Omega is the angular velocity. It is equal to, or it is also equal to v square upon r, or it is equal to v omega. We know that this v is omega r. And by putting the values, we can get the value of, or the magnitude of the acceleration as v omega. If we want to write down the vector formula for the acceleration, then it is like this. Vector formula for acceleration minus r omega square, or it is equal to minus v square upon r cap, where r cap is the unit vector along radius vector. Unit vector along the radius vector. This negative sign, it indicates that the direction of acceleration and the direction of radius vector, they are opposite to each other. They are opposite to each other. So from this equation, see, this is the acceleration, it is equal to minus r omega square, and this negative sign is indicating that the direction of acceleration is opposite to radius vector. So if this is the direction of radius vector, then this is the direction of acceleration. This is the direction of acceleration. See, the acceleration, linear acceleration of a particle, of a body which is performing uniform circular motion, it is along the radius. It is along the radius directed towards the center. The direction of acceleration is along the radius directed towards the center. So this linear acceleration is called as centripetal acceleration. It is called as centripetal acceleration. And as it is along the radius, it is also called as radial acceleration. So if this is the direction of radius vector, this is the direction of the centripetal acceleration. It is directed along the radius towards the center of the circle. And now we will move towards the force which is responsible for the circular motion. The force which is the cause of circular motion. And whenever we are studying about the cause of the motion, it is called as dynamics of the motion. Whenever we are studying about the cause of the motion, the force which is responsible for the motion, it is called as dynamics of the motion. So now we are moving towards dynamics of circular motion. And you see the force which is responsible, which is the reason for the production of circular motion, is called as centripetal. It is called as centripetal force, CPF. It is called as centripetal force. As it is centripetal force, see, if A is the position of the particle which is moving along this circular path, A is the position of the particle which is moving along this circular path, this vector indicates the centripetal force which is responsible for the circular motion. This vector indicates the direction of centripetal force which is responsible for the circular motion. And as you know that the force, it is equal to ma. We have already the formula for acceleration. Then this centripetal force, it is equal to minus mr omega square. This centripetal force, it is equal to minus mr omega square. Again, this minus sign indicates that the direction of radius vector is opposite to the direction of centripetal force. And in terms of the linear velocity, it is minus mv square upon r cap. This r cap is unit vector. This r cap is the unit vector along the radius vector. You know that this is the direction of radius vector. And now, what is the direction of centripetal force? This is the direction of centripetal force. The centripetal force is along the radius directed towards the center of the circle. And now, there is one more force. there is one more force. And we are going to study about that force, which is called as centrifugal force, which is called as centrifugal force. I'm giving the example for centrifugal force. I'm giving the example for the centrifugal force. Whenever there is a curved rod, whenever there is a curved rod, you know that along the curved road, the vehicle, it may be a car, it may be a bus, it may be a cycle. If this is the curved road, and the car is moving along the curved road, and the passengers are sitting in the car. If the car gently move towards the left, the passengers in the car gently moved towards the right. Whenever car is gently moving towards the left, the passenger inside the car or the passenger inside the bus, they are turning towards right. And this turn is due to the centrifugal force. This turn is due to the centrifugal force. I'm repeating the example. If we are moving in a car or we are moving in a bus and there is a turn along the road, the turn is towards the left. And if that car or bus is turning gently towards the left, the passengers inside the car or the passenger inside the bus, they move gently towards the right, and this turn is due to the centrifugal force. This turn is due to the centrifugal force. So centrifugal force. And if we want to give the direction, we want to talk about the direction of centrifugal force, then this is the direction of centrifugal force. This is the direction of centrifugal force. See, the vehicle, it may be a bus or it may be a car. If when the car or vehicle is moving towards left, that means this is the turn, this is the path of the vehicle. In that case, the passenger is turning towards the right. So whenever this is the path and the vehicle is moving towards this direction, then the passenger inside the vehicle, they move towards this direction. And so this force, all of us has experienced this force. All of us has experienced this force, and this force is called as centrifugal force. So this centrifugal force is directing along the radius and away from the center. It is directing along the radius, but it is directed along the away from the center. If we want to write down the points, distinguishing points between the centripetal force and centrifugal force, then we can write down at least 4 points of distinction. We can write at least 4 points of distinction between the centripetal force and centrifugal force. Now, the question about the centripetal force and centrifugal force, mostly it is distinguish between centripetal force and centrifugal force. Mostly it is distinguish between centripetal force and centrifugal force. And now we are writing down the points of distinction. We are writing down the points of distinction between centripetal force and centrifugal force. So, centripetal force, and there is centrifugal force. So we know that centripetal force is responsible. It is the main, rather it is the cause of circular motion. So what is the first point towards the side of centripetal force? It is responsible. It is responsible for circular motion. And what we can write towards the side of centrifugal force? This centrifugal force is not necessary for the production of circular motion. Rather, it is the effect of circular motion. The centrifugal force, it comes into existence after the production of circular motion. So this centrifugal force, it is the effect of circular motion. Then what is the main point of distinction? It is that the centripetal force is directed along the radius and it is directed towards the center of the circular path. It is directed towards the center of the circular path. So it is directed towards center of the circular path. Circular path. And what we can write towards the side of centrifugal force? We know that this is the direction of centrifugal force. Centrifugal force is directing away from the center of circular path. So we can write down here, it is directed away from the center of circular path. Now for the third side or third point of distinction, we can write down the formula. So formula for centripetal force, it is minus mr omega square, or it is equal to minus mv square upon r cap. But for the formula for the centrifugal force, it is, you can write down centripetal, you can write down fp, and it is centrifugal. It is equal to mr omega square. There is no minus sign because the direction of, see, if this is the circular path, this is the direction of radius vector, and this same is the direction of centrifugal force. Same is the direction of centrifugal force. So we can write down, this is the formula for centrifugal force. It is mr omega square, or it is equal to mv square upon r into r cap. So this is the main point of distinction between the centripetal force and centrifugal force. Now fourth point is that it is a real force. It is a real force. What does it mean? What does it mean? This centripetal force, it follows Newton's law of motion, Newton's laws of motion. The centripetal force, it follows Newton's laws of motion, and it can be classified in terms of gravitational force, electromagnetic force, strong nuclear force, or weak nuclear force. You know that these four forces are the fundamental forces: gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. So we can classify centripetal force between one of these four forces, and the centripetal force follows Newton's laws of motion. Now this centrifugal force, we cannot classify this force as one of these four forces. But we know that this centrifugal force, it exists. We all have experienced the centrifugal force. We all have experienced this centrifugal force. So it is called as pseudo force. It is called as pseudo force. That means it is not imaginary force, but this centrifugal force is present in non-inertial frame of reference. This centrifugal force, it is present in non-inertial frame of reference, and so it is called as pseudo force. So these 4 points are the points of distinction between centripetal force and centrifugal force. And now I am giving one example of centripetal force. See, electron is revolving around the nucleus. Electron is revolving around the nucleus in circular orbit. So that means electron is performing circular motion. So the centripetal force, which is necessary for the circular motion of electron, then there is a force of attraction between positively charged nucleus and negatively charged electron. There is a force of attraction. There is a force of attraction between positively charged nucleus and negatively charged electron, and this force of attraction is used as centripetal force for the circular motion of electron. So this is a very critical example of centripetal force. And with this point, we are stopping this lecture. Thank you.